those so that I can make sure that you guys have as much time on the quiz as possible. Okay. That's not good. I can see. So here we go. On our homework for chapter 15, part 2, we started at number 24. Okay. So the key is that you really have to read carefully the question to see if that information is a given that set of information. For example, 24A, what's the probability that someone who has traveled to Mexico? That's a fact we already know. So since that's a fact that we already know, that's a given that part. Given that you have traveled to Mexico, so out of the entire Mexico circle, what's the part that is the Canada and Mexico section? So if we were to look at this picture here, we'd see, out of this entire Mexico circle here, what's the part that is the Canada and Mexico part of that? How much is that? And so this overlap is 44% of the entire Mexico circle. All right. Now, I want you to treat the disjoint question and the independent question totally separately. We discussed a connection between those in chapter 14, but that connection happens only part of the time. It only happens the times that the problem is disjoint. Okay? So people were getting all confused on the connection, thinking that if it wasn't disjoint or whatever, they could automatically say something about the independence. So, just treat those two separately. What I want you to do is when it asks you if it's disjoint, you know it's disjoint if there is no overlap. There is no outcomes in common. Well, guess what? We know that 4% of people have gone to both Canada and Mexico, so since there is overlap, then they are not disjoint. All right. And for part C, when you have this question about independence, you should be writing a formula out. You should be writing something along these lines where then you are asked, it's a question, and you are seeing if those sides are equal to each other. Okay? So in this case, given that you have gone to Mexico, what's the probability that you've gone to Canada? Okay, I went ahead and did that in that order since part A was already done, and that's 44% chance. But probability of Canada overall is this Canada circle, and that was just 18%. Whatever this one is should be the same as that one if they're independent. What that means is if Mexico had no effect, then the probabilities would be the same. But in this case, is the fact that you've gone to Mexico having an effect on the probability of you have gone to Canada? Yes. Okay. So what I would say is that they are not independent because, and I want you to give me reason. So let's put this on there if you do not have that on there. Here's how I know they're independent. If you have gone to Mexico, so I read this part, if you've gone to Mexico, then I'm going to compare the probabilities. So if you've gone to Mexico, then you are more likely to have also traveled to Canada than just the rate at which people were traveling to Canada overall. So here I wrote, if you have gone to Mexico, it increases the probability that you have also gone to Canada. Okay, that's what's happening. All right. Now, 28 has two problems also, and again, they are asking disjoint and then independence. And then the next one is another set, disjoint and independent. And remember to do those separately. Disjoint would be outcomes that are not in common. So, this came from the table on the front of the homework. This came from this table here. And so you can see that these two rows are separate and do not have any overlap. So since the agriculture and the human ecology are separate rows, parallel to each other, and have no overlap, then what do you have to say about them being disjoint? They have no overlap? Correct. So they are disjoint, okay? So agriculture and human ecology are disjoint. Okay. That's the one case that if they are disjoint, then what's happening is if you're in one, then you're not in the other. So that's changing the probability down to 0. That's that one special case that we referenced in chapter 14. If you are disjoint, then you are not independent because it's changing the probability to 0. So what I did here was, what you should do, write out one of those formula things. Okay. Now question, would you be allowed to change the human ecology and agriculture, whatever it is? Yes. If you had put ag first, then you would have human ecology here. Just make sure that this is the same as what you have in front. Okay. All right. So in this case, they are not independent. All right. Now, the next two parts have to do with firstborn and human ecology. So here's what happens on that. Let's look at the picture, the chart on the front. Firstborn is right here, okay? Firstborn and human ecology have an overlap. They have the overlap at 15 people, or in both. So since 15 people are in both, there is overlap, and so then it's not disjoint. They are connected. It is not disjoint. Okay? Alright, so that's what we have. We have 15 students in common. Okay? And so now, to do my little independent thing, I'm going to write myself a statement. I chose, given that they are firstborn, what's the probability they're in human ecology? And then that puts human ecology overall. Actually had that wrong first. I had a student teacher, you may notice the handwriting's a little different, a couple years ago, and I went off of that. Found that mistake today. Okay, so did those numbers. This one is about 13%. This one is about 19%. So let's make a statement. Question, are the percentages the same? Percentages the same? They are not. 13% versus 19%. So since they are not the same, I wish I had some space here. Since they are not the same, they are not independent. Okay? And here's the problem that it came from. Okay, not independent. Okay, so now, why? I said because if you are, what? That's where you start. If you are firstborn, because if I know something like that, if you are firstborn, then what does that do? This percent was 13%, and this percent was 19%. So if I know you're firstborn, then you are what? Compare those percentages. Good. Then you are less likely to be human ecology major than what's on the right side? What is that? Human ecology major overall. Okay. Alright, so that's the kind of sentence I'd be expecting. To follow up, that includes the information on it. Alright, now 34, there's many different ways that you could actually write your little formula sentence on this. I wrote the one, or Miss Ray wrote this one, probability that you drive an American car, given that you are a student, is that the same as probability of American car overall? Okay. But there are other ways. You could have done staff. You could have chosen different different kind of car other than American. Okay, so there was multiple ways that you could do this. If you found that yours was the same, you actually would have to check them all. But look, the first one I did, I found that they were what? Since they are different, then I'm good. I can stop because I know if one of them's different, then they are not independent. And then I could go make a statement. Yes. The same. Well, within 1 percentage point. You know what? That's actually a little close. I probably should have found another one because I wonder if that's a rounding. That could have been a rounding thing. No, I'm not going to take the time right now. This might be something that I would consider looking for another one. I would probably go to, because this one's going to be the staff one here is going to be the 0.45. So I would probably go to the European or Asian and check and see if there's a bigger discrepancy. Okay. So that's a good point. All right. Now, I want to do number 35 from the beginning with you. Here's the deal. Number 35, and here's what should happen. In your brain, you are reading this, and you come across more than one if-then statement. If you have more than one if-then statement, you have more than one conditional probability, and then you need to organize it as a tree diagram. So look here. This says if the flight's on time, then the probability, So there's one if-then, but if the flight is delayed, then the probability, So there were two if-then statements. So that right there says to me, I need to do a tree diagram. So, here's what's happening in this problem. You start with Leah. She's going to either leave on time or she's not going to leave on time. So not on time. Up here it's on time. Alright? She will leave on time. 15% of the time she will not leave on time. The other part. Okay. Here is the two if-then statements. If she leaves on time, then her luggage will get there 95% of the time. Okay, which means it doesn't get there 5% of the time. Okay, but here's the second if-then statement. If she does not leave on time, then the luggage will get there only 65% of the time, which means it'll not get there 35% of the time. Alright, there you go. There's our tree diagram. The first question, 35A, asks, are leaving on time and luggage getting there independent? Okay. And I guess technically if you wanted to mathematically show this out, you could go through one of those little formula things and write that out. Because you have a tree diagram, it's easier to see. So let's just take one of them. If you leave on time, the probability of the luggage getting there is 95%. But if you don't leave on time, then the probability changes to just 65%. So that's the key. If the probability is changing from 95 to 65, probability changing, therefore they are not independent. Probability changing has to do with independence. Okay, so here's a statement I could make. Not independent because if you leave on time, the luggage gets there 95% of the time. But if you do not leave on time, the luggage gets there only 65% of the time. So you leaving on time or not is doing what to the luggage probability? Changing it. The fact that it's changing it makes it not independent. Okay. Alright, so that's 35A. 35B asks, what are the ways that her luggage can get there? What's the probability her luggage gets there? Okay. So, let's see. I actually highlighted in yellow. Here in yellow are the ways her luggage can get there. She can leave on time and her luggage gets there. Or she could not leave on time and her luggage gets there. So I need to put some math to that, and here's how that works. She leaves on time and her luggage gets there, plus the other way, which is do not leave on time and her luggage gets there. So if I total those up, 35B is this. Leaves on time, her luggage gets there. Plus, does not leave on time, luggage gets there. That actually comes out to 69.5%. So, just a 69.5% chance that her luggage is going to get there on time, regardless of whether she leaves or not. I mean, total. Okay. We good so far? Alright, the last one, number 37. Speak up if I'm going too fast on some of these. The last problem, number 37, it is critical that you write the problem down in the correct notation. The question says this. Let's read it. Let's look here and actually look at the way it's written. It says, suppose you pick up her at the Denver airport and her luggage is not there. Okay, so that's the fact that's known. Okay, so that's what we write here. Her luggage is not there. Okay, so given that her luggage is not there. Alright, then let's see what it's asking. It says, given that her luggage is not there, what's the probability her first flight was delayed? So, that means given that her luggage is not there, what's the probability that she did not leave on time? Okay, so that's what we're doing. If you write this, it's going to help you remember that it needs to be a fraction. You're going to then put all of the ways that what goes on the bottom. All of the ways that she has no luggage. Alright, so I'm going to highlight those in green. All of the ways that she has no luggage is on time, no luggage. Not on time, no luggage. So those numbers are, let's put numbers to it, on time, no luggage, plus not on time, no luggage. That's the total ways that she didn't get her luggage. So that's what I'm going to put down here. On time, no luggage, plus not on time, no luggage. So this is the whole ways that she has no luggage and what's the part that they want. What's on top of this fraction will always be a portion of what's on the bottom. So which part of the whole down here will be on top? The second portion, the not on time portion. Okay, so that's the part out of the whole, and when you do that, it's 97.5% chance. So if her luggage didn't get there, there's a very high chance that she did not leave on time. Okay, questions on that? Let's then go through the warm-up, okay, pretty quickly. So here we go. Alright, so please remember, when we did this warm-up on Friday, if you straight up added 34% and 39%, it was too much. Why is that 73%, but it's only supposed to make a total amount of 60% in the circles? There was overlap, and how much bigger it is, that discrepancy meant there was 13 percentage points of overlap. So that's what's there in the middle. 13%. Okay. So there's A, there's B. Look at the subtle wording of C. It says, what's the probability that a randomly selected U.S. household owns a cat if the household has a dog? That means it is known that the household has a dog. Very subtle. It doesn't give you the words. Given that, the household has a dog. But it is meaning. Okay? So it's very subtle. You're learning the language there. Alright, and so then that's what comes out to be. Number 2 was many if-then statements. If company A, the defective rate is this. If company B, then the defective rate is this. If company C, then the defective rate is this. Okay. And question says, if a worker at the manufacturing firm discovers a randomly selected computer chip is defective. So that's a fact. That has happened. So look, when you write this out, the computer chip is defective. So now, based on that, what's the probability that it came from company B? I am not looking at all chips in the whole factory. I am now only looking at a bag full of defective chips. So all of the defective chips is what goes on the bottom. And that would be A defective plus B defective plus C defective. And what's the part of the total they wanted? They want the B defective section. Okay, questions on that? If on this problem you got only 0.004, then that's the probability of picking a defective chip from company B if you are pulling from the whole factory. If you have dwindled it down to just the effective ones, then it's 34.78%. No. Because you have been told that the computer chip is defective, so that's a given that. So you now are out of just the defective bag instead of the whole thing. Okay? So that was important information. All right. Here is the breakfast and gender problem. I think A, B are pretty straightforward. C, D, and E are very subtle differences. Okay, so you have really got to be on your game on that language for C, D, and E. So this is a female and eats breakfast, so that's out of all students. It's coming out of the 331 students. But when we get to D and E, they were telling you given that. So we were given information to dwindle our bag down to just the breakfast eaters or just the females. Okay. Now, part F is one of the ones that asked for independent, so you got to write yourself out a formula. And you actually could write it 2 different ways. I did this one way, and I don't know why I scratched it out, but you could do female given breakfast, you know, and then this is female, and so those two are the same, so that was fine. They do come out not independent. But anyway, for some reason I redid it this way. Given that you are a female, what's the probability of eating breakfast? If you know you're a female, compare them. Tell me, if you know you're a female, what is happening to the probability that you have eaten breakfast this morning? It's what? It goes up. Good. If you are a female, then there's more likely a chance that you have eaten breakfast than if I did not know your gender. This is the probability of you eating breakfast if I don't know your gender. This is the probability of you eating breakfast if I know you're a female. Okay. So that knowing your gender affected the rate at which you ate breakfast. Okay. So that's all those questions. Now, what you are going to turn in with your quiz is this, Chapter 15, Part 1, Chapter 15, Part 2, and your warm-up. Yes. Okay. Okay. Let me stop this real quick.